I was asked to talk about the ethical challenges of AI in research. And just to give you a little bit of background about myself, I'm a computer scientist by training. I hold an appointment in the School of Medicine, and I've been working in biomedical informatics now for about 20 years. And some of my research over the years has obviously been in artificial intelligence and sort of different types of modeling. So a lot of the examples I'll draw upon might be from the healthcare setting, but in general, a lot of this is much more broadly applicable to any of the research that we would typically see across UCLA. So I always feel that it's appropriate to start any sort of AI type of presentation with this slide. For those of you who remember The Matrix, this is just over 2 decades ago, right? It actually premiered here in Westwood. And there's this famous scene where Morpheus is talking to Neo, Keanu Reeves, and Morpheus says, at some point in the early 21st century, all mankind was united in celebration, and we have marveled at our own magnificence as we gave birth to AI. And of course, Neo says, you mean artificial intelligence. And so they're not actually too far off the mark in terms of the date, right? Now that we see this explosion of artificial intelligence and what's been going on in terms of both the research and what we see in the media, obviously there's a lot to be discussed about artificial intelligence. So, but what is AI, right? Even though we throw this term around a lot, I find it's useful for us to actually sort of ground what we mean by AI. And so the University of California actually does have a definition for what they call AI. And there's a lot of different definitions out there that you might find, but this is the one that at least the University of California has taken on, which is technologies that aim to reproduce or exceed abilities in computational systems that would require human-like thinking to perform a wide range of tasks from simple to sophisticated. So this is a lot of words, right? What exactly does that mean? So the simplification of that statement, right, is AI in many ways tries to mimic human intelligence and decision processes, based typically on data that we give it, right? And it looks at the data, it learns certain things, an algorithm, for instance, and tries to then provide some predictions or some type of output from that. The fact of the matter is artificial intelligence is not new, right? It actually has been around for a long, long time. When you look back at the history of AI, it actually probably first started in 1943 with something called a neural network. And actually that is the basis. These neural networks are the basis now for a lot of what you see today in terms of artificial intelligence. When we talk about things like ChatGPT, other types of deep learning, they're actually based heavily on the original idea of a neural network. Subsequent to that, we got the phrase machine learning actually in 1959. And then following that, we sort of saw different type expansions of artificial intelligence looking at data. For instance, in 1967, we had this algorithm first for clustering. You see that there was a large gap from 1967 to about 2009. And what this sort of represents is in the early sort of genesis of artificial intelligence is all very theoretical, and there was a lot of constraints in both how much data was available and the computational power we had. But as you might imagine, in the 1980s, we saw the desktop PC from IBM. And moving forward from that, we then began to sort of see this increasing acceleration of both computational power and data. 2009, what we saw is something called ImageNet, which was this release of 14 million images. And this actually led to really the revolution that we see today in AI. And in 2016, which was a landmark in the sort of AI sort of computational space, Google had the program called AlphaGo. And for those of you who know what the game Go is like, it's a very computationally difficult problem. Prior to 2016, AI had sort of been the best chess masters, but Go is actually exponentially or much more problematic for computers to solve. But in 2016, it was actually able to solve the Go world champion. So, of course, all of this was sort of made popular again in media and things like that. For those of you who watch Jeopardy, you might remember that IBM Watson had, in 2011 actually won the Jeopardy challenge. You see there the sort of scene where it was declared the winner. And of course, this sort of brought this into popular culture. The fact of the matter, though, is right now AI and data science, right, are changing research across multiple domains. What we're really seeing is that these data-driven methods are driving both new insights, and these insights might come from scientific knowledge in different ways, and they promise sort of novel directions to really enhance how we do knowledge discovery. As I sort of mentioned before, there's really a couple things that are driving this. One is we now have so much more data, right? And this data is now actually computer understandable, if you will, right? A lot of it's digital, and so it can actually be processed. We also have this increase in availability of computing. It used to be that only a few groups might have a lot of computing power in order to be able to do these types of things. This has been now commercialized, right? We have things like AWS and Google and Microsoft who provide cloud computing platforms. We also have high performance computing as well. And all of this is allowing us to look at these large amounts of data. And combined with both the computing power and the data, then we have these new computational algorithms and data-driven approaches. So the combination of all three of these is really what's driving this acceleration we see in the use of AI across different domains. There are different types of artificial intelligence, and some of you who sort of see these applications of it may come across different terms. AI, again, sort of covers a lot of different things. We often hear about things like machine learning, which I tend to sort of think about as looking at things for detection and or prediction of a pattern. We also hear about things like reinforcement learning, which I like to think about as optimizing a series of actions over time, right? How do you take a set of sequential decisions in order to achieve a goal? So reinforcement learning, for instance, is what we typically see in self-driving cars, right? They're actually trying to make sure that you don't hit something, right? And you actually are able to get to your destination. And that requires a sequence of actions on the part of the car. We also hear about natural language processing, which is really about the understanding and generation of free text materials. Now, of course, the new kid on the block, of course, is generative AI, right? We hear about this all the time. For those of you who have used ChatGPT, there are other variations of this, Llama, Palm, and so forth from other different groups. And I like to think about these, even though things like ChatGPT and such are really sort of a type of deep learning, they actually do, at this point now, draw on a multitude of different techniques, both from machine learning, reinforcement learning, natural language processing. And these are all made available, again, by the enormous amount of existing data and processing power. So we'll touch upon this a little bit later as I go through this discussion. Okay, so the question really is, why do we worry about AI? And of course, if we listen to Hollywood, we're all doomed. Some of you may remember this movie, I, Robot, from 2004. And the catch line that Hollywood was using at this time, right, was in 2035, a technophobic cop investigates a crime that may have been perpetrated by a robot, which leads to a larger threat to humanity. Of course, we've had Hollywood sort of harp on this for a long time in terms of AI is bad. For those of you who remember the Terminator series, right, Skynet should have been launched by now. But that all being said, the question really is, honestly, why do we worry about AI? So it's not all bad, right? It can't be. Well, again, we sort of hear about these things in different ways. And these are two articles that have come out in the past, I guess, 6-7 years now. One is from Science, which was in 2017. And the title was, Even Artificial Intelligence Can Acquire Biases Against Race and Gender. More recently, in 2022, the Washington Post had this article, The Robots Were Trained on AI, They Became Racist and Sexist. So some of you may remember seeing this in the news. Prior to ChatGPT, Microsoft had released a chatbot, I think in about 2021, 2022, which is the reference that this Washington Post article is making. And within about 20 minutes of releasing this chatbot to the public, Microsoft had to take it offline because it had essentially gone from being a very mild-mannered response mechanism to questions and inquiries to becoming racist, right? It was actually making references to Nazi propaganda and all sorts of other bad things, and Microsoft was horrified, and literally in 20 minutes, they turned it off because it was that bad. So the truth of the matter is AI is ever only going to be as good as the data we provide the underlying algorithms. And if our data itself is flawed, its responses will be too. And there's three different talks that I would refer you to. Those two examples that I just gave you from Science and the Washington Post were drawn from Dr. Bradley Malin's talk, which was on recognizing and integrating social good into the AI development lifecycle. That was in the end of 2022 as part of an NIH series. And there's two other talks that are listed here, and you can sort of see the link here for those of you who are interested in learning more about the particulars of the data and biasing issues. It sounds, again, sort of hypothetical, but there are actual real examples of where this has actually occurred in reality. This is actually a famous paper written by Professor Obermeyer, who's at UC Berkeley. This came out, I believe, in also about 2018, 2019. And the context for this was a healthcare insurance company had developed an algorithm. Basically, they had looked at all their claims data, they looked at certain pieces of information from the electronic health record and so forth, and they had this black box algorithm which they had deployed. And Obermeyer and his group, not knowing the algorithm's internals, decided to try and reverse engineer it to see what was going on. And what they actually found, particularly in the case of the outputs of this algorithm, was for some reason it was denying in the use of, well, I'm paraphrasing here, basically sort of saying blacks should not get a certain amount of care because they don't need it per se. And the algorithm was preferentially giving care and better resources to other populations. And they were trying to understand why the algorithm was doing this. So they dug into it, and it turned out that it wasn't really the algorithm's fault per se. It was actually the data, and the algorithm had learned what physicians had already been doing. That just simply had been the bias within the data. So the algorithms that we actually train are only going to learn what we have done previously. They really can't do anything necessarily that we haven't already done before. This is obviously a real issue. When this came to light, Obermeyer and his group actually worked with that healthcare company to sort of fix the problem and everything. But the fact that the data was used in that way and that no one thought about this problem and looked for potential harm and bias in the use of AI in this case was problematic. And this actually had real outcomes on patients. So let's go forward. Okay, so what are the ethical issues around artificial intelligence? And there are a lot of socio-technical issues that really surround the development and application of AI, which we must all be aware of to really ensure its appropriate usage. And a lot of these are really complex issues. We don't necessarily have the answers today. But if we were to sort of think about what are the questions that we want to ask about the ethics and issues in AI, there's a few of them, right? Particularly for this group. One of the questions that I always sort of point out is, do people really understand the consent, right? Whether AI is being used or their data is being used towards the development of an AI method, are they actually aware of what the consent means? The second question is really, how is the data being used and by whom? And we'll dig into that question a little bit more. But a lot of times, particularly now that we have data sharing, agreements, whether through NIH or other federal agencies, there are downstream users of data sets that might be released, and the intent of the original consent may no longer necessarily be held. The third question, which kind of is reflected by the comments I made earlier, are the methods equitable and safe, right? Are we potentially using the AI methods and the development of these in an equitable way that it doesn't necessarily create harm and bias, right? And are they really safe? An increasing question that we also have about AI right now is, do the AI models themselves contain or embed sensitive data? And there's a lot of discussion about this right now, particularly with things like ChatGPT and large language models, where we do actually find that they might be embedding what we had originally thought was protected data. We're finding them actually in these models. Sort of a bigger and sort of bit of a metaphysical question here, but what if AI gets it wrong, right? What are the consequences for that? And then sort of the last question, which also sort of circles back to the question about consent. What if you consent and then you decide you want to be excluded? This also has consequences when we think about how AI is being developed, the models and the data, and what the downstream consequences of that might be, both for the individual as well as the people using the data. So I like to think about this also in two different ways when we talk about what are the ethical issues about AI and research. Really, there's two parts. One is the question of research involving the development of artificial intelligence, right? And that might be for a lot of different things. We could think about the use of artificial intelligence, for instance, in trying to optimize something in the hospital, or we might be using artificial intelligence to try and find new patterns in, say, archaeological data sets or something like that. The second part is research that uses AI to further knowledge, right? So you might be using an existing AI technique to actually infer or find new things within your an existing data set. So there's really two different parts of this, but they actually sort of intermingle, and you'll see why as we go through this. So when we also talk about the challenges around AI, right, AI and data-driven methods are really sort of these technology disruptors. And as you might imagine, they have raised many ethical, legal, and social issues, right? So the acronym of ELSI should be familiar to many of you. And this is sort of, again, going through some of the things I already touched upon. But these are pretty much the 5 categories that we typically think about when we have to consider both the ethics of AI and sort of its usage. One is harm and bias, which I've already touched upon, right? And the first thing, there are the potential issues around wrong results, the biasing, liability issues, unintended consequences, interactions from artificial intelligence methods. The second one is privacy, right? The concerns about the use of sensitive data in ways that were not originally intended, and the ethical issues around privacy and access to this data. We're increasingly sort of seeing regulation issues around AI, right? Right now, we actually have very a paucity, if you will, of guardrails around the use of AI, and we have a patchwork of policies that have not really caught up with the rights and protections that we might anticipate for our technology and the use of data as we're seeing today. There's also another question of trust, right? How do we define trust in AI? And again, that we can have a large philosophical discussion about this, but there are a lot of different stakeholders that have to be engaged in order for us to understand the utility of AI and how it can be used in a meaningful way that people do trust. The last aspect that we also consider is access, right? One of the questions that has always been at the mind of at the top of the list when a new technology is developed is who's going to have access to that technology, and will it create a digital divide? And we sort of see this already with artificial intelligence techniques and methods, particularly when we think about who do we have data on, right? We don't have data on everyone, and so we're learning models only on data for which we have, we're learning models and methods on people whom we have data. And so there's this increase in concern that we don't necessarily have data on the people we need in order to make this equitable. Okay, so when we think about using data to develop AI models, there's going back to those questions that I sort of put out there. The first question is really, do people understand the consent, right? There's a lot of issues around this because in AI, what we're seeing is an increasing use of lots of different data sources. We're using multiple types of information to create these sophisticated models. And it's not clear that people really understand how their data is being used as a result. A good example of this is something like Facebook, which collects a lot of data on its users, right? But Facebook alone, only if you were thinking, oh, they're only using the data from whatever I post or something like that, they're actually pulling in a lot of other information from other data sources and tying that to you. They're able to figure out who you are and the different profiles and basically your search behaviors and a lot of other pieces of information that aren't just from the Facebook site alone. If you think about that, and that's really sort of the direction that a lot of these AI models are going in order to pull this information together, people, when they're consenting only to Facebook, they're thinking, oh, this is just the usage of data in Facebook. However, because a lot of these information sources are available through other means, we have a challenge here in understanding really what is consent these days. And this, again, goes back to the questions of privacy and also making sure that people know how their data is being used. Obviously, this also goes then to the question of underrepresented, underserved, and marginalized groups and their understanding of the consent. What we're also finding is that a lot of people who by default will say yes to a consent are doing so because they're not really understanding what it means. And in this case, with data and how that data is being used and the potential harm that data might sort of provide if it's used incorrectly, we think it's increasingly more important that these particular groups be well aware of what they're consenting for. The second question is, how is the data being used and by whom? And I alluded to this earlier. Really, as these data sets are being shared, and particularly as a researcher who does work with large data sets, I'm sort of under the mandate now by NIH. I have to be able to share my data in order to get to scientific reproducibility and so that other scientists can build on the work that I do. The challenge, of course, here is what if that data is then used for other purposes for which it wasn't consented for, right? How is that going to be thought about and handled? And so there's a lot of complexities about this. We haven't necessarily figured out what the answers should be in this space. Third question is, what if someone wants to be excluded? So in a typical conventional study, so forget about artificial intelligence for a moment, if an individual consents and then decides, oh, you know what, I want to withdraw my consent from the study, please remove me and the data that I've provided from this study, we obviously remove that individual from consideration. This is a lot more complex now when we think about building AI models, because what we're doing is we're using those models, we're building those models off of the data that we receive. And basically the model has learned something from that data. And for someone to sort of say, oh, I would like to be excluded now, in theory, that means you should actually be removing them from that model. Now, it might not be that they are necessarily represented in that model, but you can imagine that if we did our due diligence and some individuals may state that you need to retrain that model without that individual's data. That has a lot of implications, and it may or may not necessarily be possible. We also have the other problem, which is if we have individuals who do not want to be represented within the use of these models, we need to know that we shouldn't be using an artificial intelligence model on them, right? So for sake of argument, let's say that I as an individual decide I really don't want to be a part of this data set for which an artificial intelligence model is being built. And that's okay, so I'm excluded from the data set. But let's say that the hospital decides to use that model and they don't know that I'm not actually represented in that model. We run into that problem where we don't necessarily know who's been excluded and what the inclusion or exclusion criteria were for the model, as well as how to apply it necessarily to a given individual. This also, of course, goes to certain other types of questions that we might think about here, right? When we are using data to develop these AI models. First one is the data set actually representative, right? And again, we think the data might be representative, but the challenge here is the data is only representative and useful if the model is being used on that same population. The question of generalization is a bigger question, and it's not always clear that models will generalize. We also have to look at the question of if the data itself is biased already, do we know that and can we handle that within the AI technique or the model that we developed? All of these are sort of open questions. The fact of the matter is AI models are not perfect, right? There is no such thing as a perfect AI model. They're always going to make some type of errors. And it's not AI just specifically. If you think about any risk model, for instance, that's based on conventional statistics or anything else we might sort of derive, there typically is some error associated with that modeling process. But we have to ask the question in this case, are the errors in the AI model biased, right? Are the outcomes of the models exhibiting any trends for certain subgroups, right? Is it favoring one group over another? And is the nature of the errors, what is the nature of the errors that the model is providing? So this sort of reflects back on the Obermeyer paper that I cited a few slides ago. Another question we also have to think about in terms of vetting the use of these AI models is, has the model actually been externally validated, right? And is that actually even important? A lot of times we'll develop AI models and they'll be in-house model development, right? So let's say that UCLA Health decides to develop a model and it develops it on its UCLA Health population. If that model is good for the UCLA Health population, it doesn't necessarily have to be used by another health organization, right? If it's only being used at UCLA. If you're trying to go for scientific knowledge and other things, then of course you do want to actually be able to generalize that model and it should be externally validated. You sort of see what the converse problem is, which is if you purchase someone else's AI model, particularly as it becomes commercialized, you want to know that that model is actually going to work on the data set that you have in your population. In a related way, then, this actually goes to the next question, which is how do you know if the AI model actually works, right? And so this actually is an interesting problem because if an AI method is actually being intended to perform an existing task, something that humans might already be doing, what do we have as the gold standard for comparison, right? That's not often clear in a lot of ways. The bigger problem is when we actually are asking an AI model to do something new that no human has done before, right? Then we have this bigger question of what is the basis for assessing the proper performance of the model? The third question that we also sort of think about when we're asking if we know if the AI model works is, do we actually know how the model is predicting? And this goes to a question that of explainability. And we often hear this in the AI community, and you hear in more common lingo the phrase black box, right? A lot of these deep learning and neural networks are black boxes that cannot be easily explained. And so the question, and this sort of reflects back on this principle of trust, are we able to actually use an AI model either for research or develop these models and not understand how they're getting to predictions and still trust and use them? So question of explainability is the central one right now. And then lastly, again, I alluded to this, which is, does the AI model embed the data? And what we are seeing is there are examples where large language models do actually contain the data that they were trained on. And this is obviously problematic. Okay, flipping the question a little bit to look at what about the use of AI in order to conduct research, right? So the prior slides are sort of more about the challenges of developing the AI using the data. We typically think about AI in the use of to support research in two ways: the correctness and completeness of the usage of AI. So some of the questions that we ask about the correctness are, what checks are actually in place for the AI tool to provide valid responses in all the use cases, right? Is the AI tool actually being used in an appropriate way for the purposes of that research, right? And how do we know the validity of what it is outputting in that particular case? Alongside that question, and looking at the question of validity, is what is the error profile related to the usage of that AI tool, right? You want to know where the AI method is actually going to be get it right and get it wrong ahead of time. The other sort of more nuanced question that people often don't think about in terms of the AI models and using it in research is, on what basis was the AI model optimized, right? And this is not necessarily something that is explicitly known. Often what we sort of see is people will sort of use an AI tool off the shelf without actually digging into the details. And we really don't know why or how the developer necessarily tuned or tweaked the model for the optimization. So to give you one example, you might develop an AI algorithm for the hospital that optimizes based on cost, right? We're trying to reduce cost. You could also choose a different optimization criteria, which is we're trying to improve quality of life for our patients. Now, these two are not necessarily orthogonal directions, but unless you actually know why the AI algorithm is choosing to do something and how it was tuned, you run into this particular problem of not knowing necessarily how is the usage of this AI tool going to affect things in downstream research. right? So then this, of course, also goes to this question of how's the output of the AI tool subsequently vetted, and is it even appropriate for the data set I'm using it on? There's actually also an interesting question here about the usage of synthetic data, and this actually is increasingly being seen across different domains where generative AI is being used to develop synthetic data sets. And the idea here is that in some cases, the synthetic data set in theory might be de-identified, right? So it's protecting people. There might not be enough data, so we're producing synthetic data in order to actually train these models and things like that. There's a sort of, there are multiple ELSI type of topics around the use of synthetic data today. There's again, the problem is that synthetic data may only be representative of certain populations for which we have trained the data on. So we may be inherently biasing anything subsequently by using synthetic data sets. In terms of completeness, the other sort of point here is, again, when I said AI doesn't always get it right, there's no such thing as a perfect AI model. We're often forgetting that AI tools and even humans can are not necessarily doing an exhaustive sort of search of all possible potential solutions, right? They're often typically approximations of something. And because of that, we don't necessarily know that when we're actually posing a question, for instance, to an AI tool and using it in our research, that it's actually giving us the best possible answer, right? And is it actually searching through all possibilities? Probably not, because there are assumptions made about certain things. And unless, again, you know how that set of responses is being returned to you, you run into this potential problem of whether the result sets that you actually have are complete or not. The answer it gives you may not necessarily be the best answer. It might just be the answer it can give you within a certain amount of time in order to facilitate a response. Okay, so the question, of course, now is, what are we doing about all of this, right? I've sort of posed some of these challenges, some of the problems that we're sort of seeing out there with respect to AI in research, whether it's about developing the AI or whether we're using it in the research setting. So in 2002, the White House released this blueprint for an AI Bill of Rights, right? And the sub-statement there is making automated systems work for the American people. And you see on the left-hand side this statement about building trust. And it was interesting to me when this first came out, since I do research in AI and with AI. And the thing is, one of the key examples that they actually pointed out here was in healthcare, right? And so I bolded this in this slide where it says, in America and around the world, systems supposed to help with patient care have proven unsafe, ineffective, or biased. This caught a lot of attention from my colleagues and everyone else. But of course, all of this is to sort of say that the government and sort of different regulatory groups are sort of seeing, okay, we need to actually figure out how we are going to approach AI, whether it's in sort of the consumer level, the research level, whatever it might be. And if you actually look at this AI Bill of Rights and this blueprint that they had put out in 2022, they actually divided it up into 4 different categories, which I think are actually quite useful to think about. One is, how do you actually build a safe and effective system? The second one is algorithmic discrimination protections. Third one's data privacy, and the fourth one is notice and explanation. So you can sort of see this mapping as to some of the issues that I already brought up, right? The questions about the safety and utility of a system, making sure it's not biased, making sure that the data privacy is there so people know how their data is being used, and notice and explanation. And one thing about the notice and explanation here, which I didn't talk about before, was we're still having sort of ethical debates about when something is AI generated, should we actually be disclosing that necessarily to the people who are receiving it? A good example of this might be, what if you were told that the letter you received from the DMV was generated by an artificial intelligence algorithm? How would you feel about that? Well, it's the DMV. Probably none of us would feel good anyway. But that being said, you can imagine that there are much more sensitive contexts in which if someone told you this was generated by AI and not a human, you might get upset, right? So the questions of notice and explanation are actually important. The explanation part, I think, is also interesting in the sense that if a decision was made and it was based on an AI output, right? If your health insurance claim was denied because an AI algorithm said X, should you be told about that? And the short answer might be yes, right? But again, there's a lot of debate about this, about how to approach this and where sort of the ethical and legal issues sort of come out of this. So of course, FDA and others, because we have so many other different regulatory sort of governance issues, have stepped into this, right? And in 2021, they had published this AI and machine learning based software as a medical device action plan. They've acted on it since then. And the FDA stated that AI algorithms, at least in healthcare, should be considered as a medical device that must be regulated. Now, the problem, of course, is that it remains unclear exactly what methods should necessarily fall under this classification. There's still a lot of gray zone about this. If you look at their website in 2023, the FDA sort of put out there a list of different products that they have cleared in terms of using AI and machine learning within these devices. A lot of these are in the medical imaging space. The issue, of course, is this is not a complete list, right? When I last looked at one of the lists that they had provided, there were over 500 products that had already been approved for use. But there's still open questions about FDA approvals and really what this is going to mean for the long term, particularly as these techniques are continually being updated. So there's still open questions that the FDA itself has not necessarily weighed in on. And I think they're also sitting a little bit on the fence about this to sort of see where things go. We're getting regulations and recommendations from all over. Unfortunately, the problem is that we now have a series of international, federal, and state policies that really don't articulate how to implement policies. They just give really just high-level recommendations. The National Institutes for Standards and Technology, NIST, has its sort of general sort of statements and checklist about the use of AI and what it should be doing. They have this Trustworthy and Responsible AI Resource Center, for instance. Last December, for instance, the Department of Health and Human Services came out with their statement about this, and the World Health Organization has even weighed in on this about the ethics and governance of AI for health, particularly looking at large multimodal models, right, and how that plays out. So we're getting a lot of this. The state of California even also has commented on generative AI, not specifically just to health, but more broadly as of September 2023. And what, like I said, we're seeing a lot of these different regulations and recommendations. UC Berkeley Citrus Policy Lab actually maintains a website and a database of these. And I did a quick search of this last week in preparation for this. There are presently 427 pieces of proposed and active AI legislation on the books right now. This is actually creating a lot of confusion, as you might imagine. And in reference to what the White House also released back in October of 2023 and subsequently in December, in the healthcare space, there was something called PHAVES, which a lot of different companies, academic medical centers, and other groups have signed on to. But in sort of looking at this and this press article from Health and Human Services highlights PHAVES, the biggest complaint that everyone and my colleagues have about PHAVES is it actually doesn't tell you how to implement or actually quantify any of the recommendations. It just tells you, here are the broad principles. It's up to you to interpret all of this. So we're sort of facing this particular issue of how we're actually going to do this. And again, this goes back to the problem that a lot of the legal and regulatory aspects within the AI space have really not caught up with how fast the technology is moving. So what is informing people and policy in this particular place, right? Well, the NIH, at least, is doing a lot of work in this particular case, and there are other federal agencies that are looking at this. AIM Ahead is one NIH program. So Dr. Keith Norris, who is here at UCLA, is leading the West Coast hub for AIM Ahead. But this is a national program, and it's really looking at a lot of different things, but looking at making sure that AI is applied to biomedical research and other sort of health-related issues is not going to be biased, right? And sort of both engaging underserved communities in AI, looking at how we can actually use AI to address health disparities, but the broader question of how to actually do this in a safe and ethical manner that is respective of different cultures and different peoples. And it sort of goes along with this idea that algorithms do have consequences. We actually want to make sure that when we are developing these methods and using these methods, that we understand the downstream consequences of these techniques, and that all the stakeholders, including the end people that these are going to impact, understand what is happening. The second program that, at least here at UCLA and other, again, this is a national program, is the Bridge to AI program. And this is actually an interesting one in the fact that right now it's focused on the questions of how do you do data collection for AI? That sounds like a very esoteric question, but the point of that is how do we actually generate a data set that is ethically sourced, right? And in doing so, that all the stakeholders, all the community partners, everyone is understanding both of how the data was collected, but then also how the data is going to be used. And so there's also sort of questions right now about do we need new types of licensing in order to be able to use these data sets for AI? If we were to give this data set to industry, an industry partner, for instance, what are the ethical obligations of that partner in respecting the use of that data set? There are other legal issues that are being looked at, for instance, in terms of IP and other things. But there are also, again, the Bridge Center and the Bridge to AI Consortium are looking closely at how do we actually use AI and how are we going to sort of power it in the coming years for research and then for patient care. The third thing more locally is the UC AI Council. So back in 2020, the UCOP President Drake actually established this expert group to try and figure out how is the University of California actually going to use AI, both and look at the questions of responsible procurement, development, and implementation and monitoring of AI across the University of California. And in 2021, that expert group released what you see on the right-hand side here, which is the Responsible Artificial Intelligence report, the recommendations on UC's artificial intelligence strategy. This is the first report released by any academic institution, sort of providing guidance around how AI should be used and thought about. It's co-led by myself and Alexander Bustamante, who's out of UCOP's Office of Ethics, Compliance, and Audit Services. There are active work groups right now that are trying to look at, again, how do we actually implement and provide guidance and recommendations across the different domains, whether it's legal, healthcare, regulatory aspects, and other sort of related issues as it affects the University of California. There's also from the Academic Senate being spun up specific working groups around AI, particularly as it relates to pedagogy and research. So with that, I'll stop here and take any questions. So thank you for your time.